Okay, so I know on the 6.5 assignment, on the 6.5 notes, we spent quite a bit of time reviewing on the different ways of factoring, and we only spent a short amount of time on how to actually solve using the difference of the sum of cubes and how to solve when we have problems like this, so I broke this down. I'm going to do two more examples. This is going to go right along with problems numbers 1 through 6 on your assignment, and I did two more problems on problems that will go along with 7 through 12 on your assignment. So these are the things that you need to focus most on your assignment. You'll notice I changed the schedule around a little bit, so Friday is just completing your assignment. So how do we do this? Now, most people would look at this and want to add 27, divide by 64, and take some kind of a cube root. We don't want to do that because when we see x to the third power, we know that our final answer, we should have 3 solutions. We know this because the degree is 3. So that's kind of our hint right away. We're looking for 3 solutions. Okay. Now we have this rule, and it says that if you have a cubed minus b cubed, 64 is a cubic number, and 27 is a cubic number, and x to the third is a cubic number. So if we have this, we can factor it into a minus b times a squared plus ab plus b squared. So all we have to do is figure out, well, what would your a value be and what would your b value be? So looking at this, what do you cube to get 64x to the third? That's going to be our a value. We would cube 4x. If I take 4 to the power of 3, I get 64. X to the power of 3 is x cubed. Our b value, now remember, don't look at the sign. The sign is going to be taken care of for you in the rule that we're using. So the b value, what do you cube to get 27? Cube 3. 3 to the third power is 27. Okay, so now what we're going to do is we're going to use our a value and our b value to write it in this form. So we know this is set equal to 0. We know of a trinomial and a binomial. This is what we're going for. Our a value is 4x, so 4x comes first. Subtraction sign. The b value comes next. It's 3. Next is a squared. Well, a is 4x. So we're doing a times a, or 4x times 4x, which is 16x squared, plus multiply a and b together. 4x times 3 is 12x. Plus b squared, plus b times b is 3 times 3 is 9. Now, that is the difficult part. Let's try it again, but let's try this one down here, and then we'll come back up and we'll actually solve this. Okay. Now, this one is using a different scenario. Again, this one's also going to have 3 solutions. But this one's going to use the other rule. It's going to use a cubed plus b cubed, which turns into a plus b times a squared minus a times b plus b squared. Now, when you go to do this, again, don't pay attention to the signs because the signs are built into our rule. So, what do we cube in order to get x cubed? A is going to become x. What do we cube in order to get 8? B is going to become 2. We fill it into our rule. A comes first, but a is x, plus b is 2. Take a and square it. X squared is x squared. We have a minus sign. Take a and b, multiply them together. A and b is x times 2, which is 2x, plus take b and square it. 2 squared, or 2 times 2 is 4. There we did it. We factored this difference or the sum of cubes. Okay. Now let's talk about how to actually solve this now that we have it in factored form. If this could factor further, our rule would have come up with that. It doesn't, though. This will never be factorable. But one way you can solve a quadratic is using quadratic formula. So that's kind of another key point that we want to probably put over here. X equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. That's what we're going to use to solve that quadratic. Now, in factored form, all you're doing is you're setting both of the factors equal to 0. So either that equals 0 or this equals 0. Now this one, you guys know how to solve it. Add 3 on both sides. Divide by 4 on both sides. X equals 3/4 is 1 out of our 3 solutions. So we're a third of the way there. This one's going to take a little bit of work. To solve a quadratic, you have 3 options. Solve by graphing, solve by factoring, or quadratic formula. I told you that this is not going to be factorable. If it's not factorable, then it probably is not going to give us nice things on graphs, so go with your quadratic formula. You have to solve this using quadratic formula. So, x equals, the opposite of b is negative 12, plus or minus the square root of 12 squared minus 4. Your a value is 16, your c value is 9. All over 2 times our a value is 16. Now we go and we actually have to figure out what's this number under the radical. 12 squared minus 4 times our a value is 16, our c value is 9. Negative 432. Two times 16 is going to be 32. And now we have to go over here to our scrap paper because we're going to have to figure out how to break down the square root of negative 432. I know right away that the negative comes out as an I, but now I'm going to have to try to find a perfect square that goes into 432. 432 divided by 4. 4 works, but there probably will be a bigger number. How about 16? 16 works, but there's still a perfect square that goes into 27, so there's got to be a bigger number. 25 is not going to be good. How about 36? 36 works, but there's still a perfect square that goes into 12. All right, here we go. 144, and I only have 3 left, and there's not a perfect square that goes into 3. So what I'm going to do is I'm going to break apart 432. I have I times the square root of 144 times the square root of 3. 144 times 3 gets us 432. That then turns into 12i square roots of 3. So what I'm going to do is I'm going to replace the 12i square roots of 3 over here. So I'm going to rewrite this. Now I'm almost done. I need to write negative 12 over 32 plus or minus 12 over 32 I square roots of 3. And I'm going to have to reduce those fractions. I'm going to work this way. Okay, now 12 over 32 reduces. If you want to be really lazy, you could type it into your calculator and have it convert it for you, which is negative 3/8. And once we get it there, we're done. However, some people still get confused because how many solutions are we supposed to have? We're supposed to have 3. And a lot of people look at this and think there's only 2. There is more than 2 solutions here because this accounts for 2. That plus or minus tells us there's 2 there and 1 there. We did find all 3 solutions. Let's try it on this one down here. I have them broken up into my factored form. I'm going to take my factored form. I'm going to set each of my factors equal to 0. This one's easy to solve. X equals -2, and we're done. This one is the tricky one, because we're going to have to use quadratic formula. So x equals the opposite of b. Your b is -2, so it's going to be 2, plus or minus the square root, -2 squared minus 4 times your a value is 1, your c value is 4, all over 2 times our a value is 1. Plug that into your calculator. Make sure you use parentheses around that negative sign, otherwise you're going to get the wrong answer. -12 is what's under there. Okay. Now we want to take that, and we're going to have to do a little side work here and figure out the square root of -12. Now that one's a little bit easier. I square roots of 12. You can probably even do this one in your head because you know 4 goes into it. We picked 4 because it's a perfect square. The square root of 4 is 2, so we have 2i square roots of 3. We're going to replace that square root of -12 with 2i square roots of 3. Now we just write it as 2 over 2 and 2 over 2. But wait a minute, 2 over 2 is just 1, so that's going to become 1, plus or minus 1 I square roots of 3. So our actual answer here is x equals 1 plus or minus 1i, or just I square roots of 3. You don't even have to put the 1 there. Again, because of that plus or minus, this is actually 2 of our solutions. There's our third solution, and we found all 3 solutions.